Well, hello, I'm back, and you're back too, which is a great thing. It means it's time for us to start day 3 of our journey together. And day 3, we've already done building an agentic workflow for the first time, and we've talked about patterns, and now we're going to talk about orchestrating between LLMs and many of them. So this is going to be a practical day. You'll be pleased to hear it's about time we got some more coding, and we're going to be calling a lot of LLMs. And I just want to, of course, say a few things up front. We're going to be calling both paid APIs and also open source models. And we're going to be calling them both in the cloud and also open source models locally, and doing it throughout this course. And I want to be clear that you have complete flexibility to decide which models you pick at which point. I'm going to have coded it one way, but a great exercise is to take what I've done and apply it to other models. And if you don't want to spend a dime, you don't need to. You can do this all using local models, although performance might vary. You can see the results I get from the models I use and try and see what you can achieve with free open source models as well. And if you want more information on what it's like to select models, whether they're open or closed source, apply them and deploy them, then you should take a look at my other course. We're not going to be covering that in detail here because otherwise I feel like it's going to be too much of a rabbit hole and we'll get distracted. So I'm assuming you're coming into this knowing about the different kinds of models and having a sense of what makes sense for closed source, open source, and so on. If you don't have that, you can either just go along with it, just sort of pick it up as we go, or of course you could always turn to look at my other course, or I'll try and put some more background information in the guides as well, because that won't be required. You can just go with the flow in terms of how we pick models. So let's talk about the cast of characters, the different models that we're going to be experiencing now. So the first model needs no introduction, really. It is, of course, the model GPT-4o Mini from OpenAI. We've already used it in a couple of calls. It's for sure the most well-known of the models out there. And of course, there's also GPT-4o, the bigger cousin of GPT-4o Mini. And then there are the reasoning models, which are models that have been trained to think through their steps in an agentic-like way, in like a workflow of thinking through the different steps before they arrive at their conclusion, because it turns out that when you ask an LLM to think through its steps, you get much better outcomes. So we may take a look at some point at O1 and O3 Mini, but it's less essential for this course. Most of the time, we're going to be sticking with GPT-4o Mini. Now, and OpenAI's great rival, of course, their competitor is Anthropic, that was actually started by a couple of people from OpenAI originally. And we'll be looking at some of their models, but Claude 3.7 Sonnet is the model that I will spend most time on. And if you want to have a cheaper version, you can go with the Claude 3 Haiku, which is significantly lower cost. But Sonnet is also fairly cheap. For Google, we're going to be using Gemini 2.0 Flash. There is also the Pro version of that too, but I think we'll stick with Flash. And as of right now, Flash is actually free, at least as long as you use it within certain usage limits. I don't know how long that'll be the case for, but by all means, if you want to use a frontier model without paying for it, then Gemini might be your path. Do look into that. DeepSeek. DeepSeek, of course, is the Chinese upstart startup that shocked us all by coming up with such a powerful model in the form of DeepSeek V3 and R1. And it's important to understand that what made DeepSeek so sensational was not necessarily that their model was the strongest in the world, because it wasn't. It was slightly behind the latest from OpenAI. But that they developed such powerful techniques to train DeepSeek to be that good, that it cost them a fraction of the spend that OpenAI had spent to train GPT-4o Mini and train GPT-4o and O1. DeepSeek was able to achieve very similar performance, pretty much comparable at a fraction. I think it's like 30 times less spend. That was the true innovation. That's the remarkable thing about DeepSeek. And also that they open source the model so that you can use it. But the major model has 671 billion parameters, which means it's far too big for anyone to run that on their computers. But there are versions of it, small versions of it, called the distilled versions, which are in fact themselves just smaller models. They're versions of Llama and Quen, two different models that have been fine-tuned on data generated by the big DeepSeek. And those smaller distilled versions of DeepSeek are for sure available free of charge. Grok. We will also be using Grok. And there are two Groks, confusingly if you don't know this. Grok, spelt with a K at the end, is the name of the model that comes from the company formerly known as Twitter, now X. X is Grok. And we might use Grok with a K at some point as well, not in today's lab. But Grok with a Q is something different. Grok with a Q is a company that has come up with a really cheap, fast way to run inference, runtime models like Llama 3.3, which is the massive version of Llama with 70 billion parameters. So you can run Llama 3.3 really fast, really low cost on Grok's infrastructure, and along with many other open source models, including DeepSeek variants. So Grok is great to use for that. And then Ollama. So Ollama is itself more of a platform. It's something that you can use to run something locally that provides endpoints locally that are consistent, very similar to the endpoints that OpenAI and other models here have, so that you can make local calls to an API, which is in fact going to just run an open source model locally on your computer in high performance optimized C++ using a library called Llama CPP. And so Ollama is something that we will use as well. Now, if some of these terms are unfamiliar to you, terms like inference, if you're not sure about that, if you don't know, if you don't fully understand the difference between running something over Ollama or Grok, then I can suggest background materials, look in the guides, and also consider whether you'd like to look at my LLM engineering course, which does cover all of this. And the final point that I will make is that you may know that I'm something of a fanatic on leaderboards, on places you can go to read about metrics and performance of different models. So much so that I was called a leader bore, humorously by my great friend John Crone on his Super Data Science podcast. But there is a website called Vellum's Leaderboard, which I've given the web address right there. And that is a great resource because it compares a number of the leading closed source and open source models together side by side. And it has things like the costs, and it has the context window size, if you're familiar with that. And it has the cost you can calculate based on the number of input and output tokens. And it's also got the performance, the results of key benchmarks across a number of dimensions. So I strongly encourage people to go and check out the Vellum leaderboard, and there'll be a link in the resources. And it's great to have that bookmarked up. And as you go through different APIs, use that to gauge the costs and capabilities associated with them. And now I'm going to put up one more time something that I said to you in the first lecture, but just to really double down on this, I want to remind you that there are great resources all over the place for this course. There's a resource for the whole course with videos and links. There's GitHub, the repo that has guides, it has the troubleshooting, and I'm always updating the labs to keep them up to date. I might add on new models. The models that we just went through a moment ago, those are the models that right now are the latest and greatest, but as new versions come out, I will update the labs so you've got the latest in there. And so, you know, what you've heard is one story, but you'll get an even better story when you go through the labs yourselves. And I will also urge you to keep a thick skin. You will hit roadblocks. There will be problems. That's one thing I can say for sure, but see them as this is where real learning happens. It's in debugging, it's in diagnosing and figuring things out. Even if it's painful to start with, it's super satisfying when you fix it and get it on track. And that is the way to do it. And if all else fails, or as I say, or if not all else fails, you just want to, then reach out and contact me. Of course, one more time, I've got my LinkedIn right there, but also you can email me. I've got my details all over the place, and I like hearing from people. I'm responsive, but most importantly, I don't want you to be suffering in pain with problems. I want to be fixing them. So keep this in mind. And also, I mean, ask ChatGPT. You do tend to get great answers. Honestly, it's amazing. And I tend to, when I have a really difficult question, I will often ask ChatGPT and Claude both, because sometimes you get answers that are too long-winded or take you in too many different directions. And so asking a couple of different models can help. And you can also basically have like an agent workflow that you do manually. You can ask a question to ChatGPT, And then to Claude, you can say, I've got this response to my question. Do you agree? Is this accurate? You can have it be the evaluator, like the evaluator optimizer pattern that we looked at a moment ago. So that's really cool that you can do it manually. And it's a great technique to get good answers from LLMs when you're stuck yourself. Okay, with that preamble, it's time for our next lab. Let's get to it. So here we are back in Cursor, a great place to be. So on the left is our directory structure. I open up the Foundations folder and I'm going to go to Lab 2, which is what we're doing right now. Welcome to the second lab, week 1, day 3. We're going to work with a lot of models. Now, let me start with just some quick points. First of all, I want to mention that the way that I like to do this, the way that I collaborate with you may be different to some other courses that you've taken. And it's something that is a bit controversial. Some people like it, some people don't like it. And I hope that you'll get used to it. Typically, I don't like to just sit here typing code because I feel like that slows down the momentum. Rather, I look at cells, I explain what they do, I run them, I inspect them, I print them, and that's what I recommend you do as well. Watch while I go through this and explain it, and then come back afterwards and run it yourself, and then add in print statements, change things, experiment. It's all about experimentation, and that's what you should be doing. So for people that would prefer it, if I sat here typing, I'm sorry. I will try and do it from time to time. I'm going to do it right here. I will do it occasionally, but most of the time I'm going to explain what I'm doing. And I hope you'll get used to that and you'll see that there are pros and cons of everything, but that's the way I like to do it. Now, one thing I will really encourage you is written here, that once you've gone through this and made some changes, done the exercises perhaps, it would be fabulous if you were willing to save your changes in the folder called Community Contributions and raise a PR, a pull request for me to merge that into the repo so that other students get to benefit from this as well. To my great joy, for my other course, there have been hundreds of PRs. There are tons of examples from people like you taking the course and submitting what they do with all sorts of fun and interesting examples. And it's been a real joy to see. And it's also been valuable for other students to experiment with people's contributions. So it's a fabulous thing to do. I really encourage it. In addition to that, something which is a good career thing to try is it's good if you have your own GitHub repo. And as you work on different projects, put some of your own stuff there as well. Showcase the work that you're doing. And if you put a post on LinkedIn to talk about some of the projects that you've worked on or some of the things you've done or what you've learned from it, and you tag me on it so that I get a notification in LinkedIn, then when I see that, I'll come in and I'll weigh in and I'll make sure that I post something there as well. And that amplifies what you're doing. It means that it goes out to all the other people I'm connected with on this course, and people can then weigh in with their thoughts too. And it helps to draw attention to the skills you're acquiring, your expertise and your examples. And that's the kind of thing that might attract the attention perhaps of a future client of yours, someone that might contact you for some business, and potentially even a future employer as well. So it's a great thing to do. I strongly encourage it, and I'll be here to amplify the work that you do. Okay, let's get on with it. So it begins, of course, with some imports, and I press Shift-Enter to run these imports. Be sure to run the imports or you will get name errors. Okay, so always remember to do this as the comment. What is that? Well, it is, of course, doing a load.env to bring in the environment variables. And you remember that I like to have override is true to avoid any existing environment variables taking priority. So that has happened. So now that that's run, what we should find is that we've got a bunch of environment variables. Now, I've been quite greedy and I've set up a bunch of different APIs, and I don't expect you to do the same. But should you wish to, here are all of the APIs that you could set up, and I have done so and I have enjoyed it. OpenAI, Anthropic, Google's Gemini, DeepSeek, and Grok. It's worth mentioning Grok, as when I did it at least, doesn't have like an upfront, a minimum. You only pay for what you use, and it's really cheap. So this is a good one to try. DeepSeek has a $2 upfront, at least it did for me, and then you draw down against that $2, and I haven't been able to spend $2. Gemini is free for within certain tiering. And Anthropic and OpenAI both require an upfront, which I believe is $5 in the US for both, although OpenAI appears to have a new deal right now, which I don't know how long that will last for, but you could always go and check it out. So this code here will load in the environment variables and just check that these keys look right if you're using them. And when I run this, it gets this print here, and you can see that I've got keys that look like they should look, all with the right kinds of prefixes. And if you run this cell and you haven't set up some of these keys, you'll get some sort of not set, but don't worry about that. Just don't call that particular model. Okay. And now, to get started, we're going to make a bunch of different calls to LLMs, and there's two objectives for this. One of them is just to show you the different kinds of APIs, the different style of messaging that we have with different LLMs, so you get a sense of it, because we'll be talking to lots of LLMs over the next few weeks. And the other is to do some orchestration between models, a few of the design patterns that we talked about last time, to see how that works out. So the first thing we're going to do here is we have a question. We're going to have a request. Please come up with a challenging, nuanced question that I can ask a number of LLMs to evaluate their intelligence. Please answer only with the question, no explanation. So that's going in a variable called request, and into a variable called messages, we're going to have this standard OpenAI construct. Role is user. The content is going to be this request that we have right here. So in fact, what I'm going to do is I'm going to add another code cell here. Let's run this. And I'm just going to print messages just so you see this, just in case it's not completely clear to you. It's a list of dictionaries, role, user, content, and there's the content. Now, people who've been on my prior course or generally know about these things might be wondering why there isn't a system message. Well, we often do talk about the need for a system message and a user message, but system messages are optional. You don't need one, particularly if it is a kind of standard, you are a helpful assistant, then you don't need to say it. It will work perfectly well without it, as you will see. Let's give it a try. We're going to use the same API structure that we did last time, that hopefully most of you are pretty familiar with, and that Cursor will just fill in for you if you start typing this anyway. We create a new instance of the OpenAI Python client library, and we call openai.chat.completions.create. We pass in the model. We're going to use the cheap GPT-4o mini. We pass in this list of dicts, and we get back and we ask for the choices0.message.content, and we'll print it. And we're putting it in a variable called question. Let's see what we get. So how would you analyze the ethical implications of using AI in predictive policing? Wow, considering factors such as bias, accountability, and societal impact. That is a good question. Goodness. Wow. Okay. That's a hard question for sure. This is going to be an interesting challenge. We will see what happens next. Okay. So what I'm going to do next is I'm going to first set up an empty list called competitors, a list that we will be filling up with different names of competitors. And I'm then going to have another list, which I'm going to call answers. And that's going to be where we will fill up different answers from different LLMs answering this question. And then we will put together the messages that we're going to say to them. And I love the way Cursor does this, but this is exactly what we want. We want a list of dicts, a role is user. The content will be this question, the exact question that GPT-4o mini just asked us. Okay, we're now going to go through, and I need to remember to run that cell. We'll run that cell and we will go through and ask some models. And why not start with the same model that came up with the question? We will start by asking GPT-4o mini its own question. So this is what we do. We're going to have a variable model name, which we will put GPT-4o mini in. And then we will say response is openai.chat.completions.create. That's standard API. We pass in the model name. We pass in the messages that we've got right here. And then we take back the answer, choices 0 message content. We will print that answer. Let's do better than print it. Let's use Markdown instead. So we'll say display Markdown answer so that we get to see it in a nice format, because you know these models love to respond in Markdown. And then we will add GPT-4o mini to our competitors, and we will add that answer to our list of answers. Sound good? Let's give this a try. So it's running. While it's running, take a look, and whilst you should never need to memorize these APIs because it will always fill it in for you, it's good to have an instinct for what this API looks like, the chat completions API. All right, so here came the response. It was, of course, in beautiful Markdown. And you can see I'm not going to read it through now live with you, but it looks like it's a pretty robust answer that has good categories and a bunch of different sections and a conclusion. The ethical implications are complex and multifaceted. Okay, fair enough. That's good. That's GPT-4o mini. We will now move on to another API. So next up, we're going to ask Anthropic, and we're going to ask Claude 3.7 Sonnet latest. So one of the things you'll see here is that Claude's API, Anthropic's API, is slightly different. As before, we're going to create a new instance of the client Python library, Anthropic, and we're going to call it Claude. You'll see that the API is slightly different. It's claude.messages.create. And again, cursor will fill that in for you. But otherwise, we pass in the model name and the messages. And actually, Anthropic needs you to specify the maximum number of tokens it's allowed to generate before it stops. OpenAI doesn't require that, but Claude Anthropic does. But other than that, this is exactly the same code. We have a model name, we get back the answer, we'll display it, and let's see how Anthropic does when we ask Claude 3.7 Sonnet latest, one of the best models that there are, the same question. So it's interesting that the headlines look kind of similar. It's more concise, which may be why it ran faster. And it seems like it's a pretty clear, well-articulated answer. No surprise. Okay, so now we're going to use Gemini. We're going to call Google's Gemini to get its answer. And here is the API. And there's going to be a bit of a surprise in here if you're not aware of this. When we set up Gemini, you'll be surprised to see that we do it using OpenAI's code. And that might be super confusing. Like, why? How come we're using OpenAI to call Gemini? Well, remember, I mentioned to you that this code, OpenAI, there's nothing fancy here. This isn't like an LLM or anything about like a neural network going on. This is a lightweight library that just wraps HTTP calls to an endpoint of a particular structure, a well-known structure that includes passing in lists of dicks and that kind of thing in the form of an HTTP request. And OpenAI built these endpoints, and they became very, very popular. And a lot of people decided that they would offer endpoints with exactly the same format, the same kind of spec as OpenAI. In fact, pretty much everyone has done that. Everyone, that is, apart from Anthropic. At least in today's examples, Anthropic is the only place that hasn't gone with this. But for all of the others, they have done in such a way that, and kindly, OpenAI opened up their Python client library so that when you create a new Python client instance, you can pass in a base URL. You can say, look, I don't actually want you to contact OpenAI on their endpoints. I would like to switch you to using Google's endpoints. And in particular, Google has an endpoint, which you'll see, again, somewhat confusingly, ends OpenAI. And that's because this is Google saying, hey, look, we've got endpoints you can use to call Gemini. And they have a particular format. But by the way, we've made special ones that have exactly the same format as OpenAI, and they're served on this URL. So you can use OpenAI's client library. You can pass in our key, the Google key, and tell OpenAI to use our endpoint that's in their format. And that will work great. I hope you followed me there. If not, you're going to pick it up because we're going to do this all the time. What you're going to see is that once we've created Gemini, and we're going to use Gemini 2.0 Flash, we then call Gemini.chat.completions.create. It's the same thing, obviously. We pass in the model name and the messages. We get back the response in exactly the same way, using now the structure that you're super familiar with. We'll display the answer, and enough chitter chatter. Let's see what Gemini makes of this, how Gemini 2.0 Flash is able to answer this question. And here we go. You can see, oh, it's quite a lengthy answer. There's a lot in there with mitigation strategies. I don't think I saw that others had that. And then a framework for ethical assessment at the end. So there's lots to like about this one, certainly. All right, next up is DeepSeek. So there are a lot of different ways to call DeepSeek, which can be confusing. But In this case, we're calling the largest, the full-sized version of DeepSeek's model. It has 671 billion parameters. It's a big model, and DeepSeek runs it and provides an API to connect with it. And to use that API, DeepSeek also says you can just use OpenAI's library, just tell it this is the base URL. And as it happens, I do believe DeepSeek only supports the OpenAI library. They don't have their own. They just say, just use OpenAI's. Everyone does. It's great. So that's what we do here. We call DeepSeek using OpenAI's library, and we provide in a key. There are two models that DeepSeek most commonly offers: DeepSeek Chat and DeepSeek Reasoning. DeepSeek Reasoning is the famous R1 model. And the reason I'm not using it here is that I want everyone to be on even footing, and we're not going to be using reasoning models for this question, just the chat models. So other than that, it's exactly the same. It's deepseek.chat.completions.create, pass in the model name and the messages, get back the answer, print it. And as before, we're adding it to competitors and to the answers. We'll give DeepSeek a minute to think this one through. I do believe that DeepSeek takes longer over this because it does come up with quite a lengthy answer. So I may have to keep this sentence moving for a long time. While I'm doing it, you can see that what's coming up is going to be Grok. All right, but let's have a look. Here we go. It is quite a long answer. There are frameworks to consider, a bit similar to Gemini, but looking very robust. All right, so that's DeepSeek. So as I said, we're now going to come on to Grok. So remember, this is Grok with a Q, not Grok with a K. That means we're dealing with Grok, the provider of fast inference on specialist hardware. They've built their own kind of hardware that's really, really fast at this. And they also support using OpenAI's library. They have their own too, but you can use OpenAI's. You pass in their key and the base URL, which looks like that. And you can see, as with Google, they've got an endpoint which has the word OpenAI in it because it's an endpoint that's designed to be compatible with OpenAI. The model we're going to use is Llama 3.3, the latest, biggest Llama 3 in the Llama 3 series. And it's got 70 billion parameters. It's very powerful. It's very impressive for that size. I believe it's either on par with or even outperforms the 405 billion version of the Llama model from before, from Llama 3.1. So it's a very powerful model indeed. Otherwise, this is the same. And of course, this will take a very long time because it's a big model. Of course, it won't take any time at all because it's Grok, and Grok is super fast. Look at all of this that got generated in just a second or two. It is really cool using Grok because it's so fast like that. And we're seeing, again, a lot of stuff that looks familiar now. I guess mitigation strategies come up a lot. Okay, and the next one, we're gonna switch tactic. We're gonna move to using Ollama. So just to explain again what Ollama is, it is a local service. It's a piece of software that runs on your local computer, and it provides an endpoint, a web service that you can call running on localhost. So you'll be able to go to localhost and then some port and be able to talk to it. And the endpoint that it offers is compatible with OpenAI, the same kind of endpoint that we've been using in all of these other examples, except for Anthropic. It has that same endpoint. And when you hit that endpoint, it has some highly optimized C++ code to run open source models locally on your box. And it should be said that it can only run small models because running it on your box directly unless you have a really big computer, unless you have like a Bitcoin miner, a mining rig, or a big gaming box, then it's going to be problematic to run a large model. Just small models will work fine. And that's what we'll do right now. So if you don't have Ollama, you can install it, and it's very easy to install. There's a link right here. If you click on that link, it will bring up ollama.com. You press the download button, follow a couple of instructions, and it will be installed. That's all there is to it. Once you follow these instructions, you should be able to go to this here, localhost, my box, at port 11434, and you should see what I see right here. Ollama is running, and that tells you that all is well. So if it doesn't say that, you might need to first restart Cursor, maybe even reboot your computer, and then open up a terminal with which you can do with the control and the tick button like this. And then you can type Ollama serve, and that should then work. And you should then be able to go there and see it running. Here are some other useful commands that you might want to know about for Ollama. But let me make this very important point that I put as super important. Ignore me at your peril, because many people ignored it when I said it before, and it's caused people distress. Llama 3.3, that is the same model that we use with Grok up here. Llama 3.3 is a massive model with 70 billion parameters. It is way too big for most people's computers, including mine. And it takes like 100 gigabytes of space, and it's really, or maybe it's like 60, I'm exaggerating now, but it's big. And it's not something that can fit in the memory of most computers. And unfortunately, Ollama does tend to have that in its sort of default recommended model, which confuses people. And some people have tried to use it, and it completely swallows up all of their computer resources. So steer clear of Llama 3.3 for running on your box. Instead, use a nice model like Llama 3.2, which is a nice few 3 billion parameters. You can also do an even smaller one, Llama 3.2:1b. And there's also plenty of other models that are very popular. Qwen from Alibaba Cloud, Gemma is Google's small open source model, Phi from Microsoft, or DeepSeek has these distilled versions of the model, which are, as I mentioned before, I think they're actually other models, they're Qwen and they're Llama, that have been trained on DeepSeek's data, on synthetic data generated by DeepSeek. To see all of the different models, you can go to this models page in Ollama. It's just on this models tab, and you can read about all of the different models that are out there and see the different sizes they come in. And really 7 or 8 billion or less is best. I'd stick with 1.5 billion or 3 billion if you can. That's the right kind of size. And once you've done that, you can run Ollama pull like this. You probably know that putting an exclamation mark in front of a command like this in Jupyter means this isn't Jupyter, in Cursor. Putting an exclamation mark inside a notebook like this means this isn't Python code. This is a command that needs to be run as like a terminal command. And so it runs it in a little terminal right here. So it's worth knowing that trick. So we run Ollama pull 3.2 to make sure that we've got that model locally. And then finally, here we go. We use the same client library as if we're calling OpenAI, but we're not calling OpenAI. We're calling localhost, our local box, this URL right here. The API key doesn't matter. Something has to be provided, but it could be anything you want. Just put the word Ollama in there is what people tend to do. The model name, Llama 3.2, that must match whatever you've pulled locally. The model needs to be there. And then the same chat completions create. Let's see what the little Llama 3.2 that's now going to be running on my computer, chugging away through its 3 billion parameters using fast C++ code. And here it is. It's done a slightly mediocre job. It seems to have sort of got bored after point 3. It's a point 1, point 2, and so yeah, nice try, but obviously this is a really challenging question, and it may be shown the limits of a smaller model like Llama 3.2, but it's still a perfectly pleasant answer. All right, when we come back, we're going to actually be starting to look at everything and doing some judging. Okay, so it's time to evaluate who did best. And what better way to evaluate who did best than to use an LLM for this task? It would be tedious to have to read through all of these and decide. First, let's just understand where we are. So we had 2 lists. One was called competitors and one was called answers. I love the way Cursor does that. And so we can just print them out and we'll see that we've got these 2 lists. There they are. These are our competitors. I hope you recognize them. And these are their answers. So one thing that's nice to do right now, it would be sort of nicer to be able to pair these up and say which one is which. There's a really useful Python function called zip that is worth knowing about. It's like a pro thing to use. And you can iterate through these 2 collections together like this. I can say for, look, what am I doing here? I just press tab. You can say for competitor and answer. Those are 2 we want to be iterating through, competitors and answers. And if you say zip competitors answers, then it will just iterate through these 2 lists together, and competitor and answer will have each one. And it's written all the code for me. That's exactly what I wanted to do. So if I do this now, you'll see that it's printing each competitor and its answer one after another. Very nice. Okay, but let's bring it together into one string called together. And I also wanted to show another construct here called enumerate. If you have a list like answers, a list of things, and you want to iterate through them, but you also want to track the index number as you do, you probably, like people that don't know about enumerate, often have a kind of count equals 0, count plus equals 1 in your loop. Not needed. Enumerate is a nice little trick. You can say for index, comma answer in enumerate answers, and then you will just step through. And so we will say response from competitor, and we're going to add 1 to the index so that the first one is competitor number 1 rather than competitor number 0, which just doesn't sound as nice. So we'll run that, and then why don't I just show you what that looks like, but I'm sure you believe me. It looks like this. Hang on, if I print it, we'll see it looking a bit more pleasant than that. Here you go. So you can see response. Oh, look at that. There's a mistake. Just as well, I did print it, isn't it? That's the benefit of printing these things. You do that, then you get to see what's going on. Wow. Okay, I hope you caught that. That's embarrassing, but I think I'll keep it so you get to see that not only can one make mistakes, but this gives you a great way to inspect what's going on and see what's happening. So when I print that now, we see response from competitor 1, and presumably down below it will have response from competitor 2. All right. So now we're going to have a new bit of text. You are judging a competition between that many competitors. Each model has been given this question. Your job is to evaluate each response. And there is the, we say we want you to respond in JSON and only in JSON and follow this format. A JSON with results and then a competitor number, a second best competitor number, third best competitor number, and so on. And here are results from the competitors, and now respond with the JSON, with the ranked order of the competitors, nothing else. Do not include number formatting or code blocks. So just a few things to point out about this. First of all, you may not be familiar with the triple quotes. If you use triple quotes in a Python string, you get to have an entire block of text without needing lots of quote marks and pluses and things. So this is a nice trick for a block of text. It's also, of course, used for doc strings. So I'm sure you have come across it before. Another thing to know is that I've sort of assumed you're familiar with F strings before, but one nice trick to know is that if you actually want to have a curly brace within your string, then you can do that by having 2 curly braces in an F string. So that's why there are 2 curly braces here, because we actually want 1 curly brace to appear in the string itself. We don't want this to be interpreted as code. All right. So with that, if I print this to show you what on earth I'm prattling away about, what you should see is you're judging a competition between 6 competitors. Each model has been given this question. Your job is to evaluate. Here is the how to give us the results, and here are the responses from each. And there you see it in there. I'm also going to mention, you see at the end here, I say, do not include markdown formatting or code blocks. It's always worth doing that. Otherwise, these models love to add in a little extra JSON tag around things. So if you use this text, then you make sure you get pure JSON back. Okay, so now that we've got this all set up, we're going to put this into messages, and then we're going to call an LLM and get our results. Let's do that. Okay, it's judgment time. So we're going to put this judge text into a messages list as usual with a normal structure. And now let's choose a judge. So I'm picking O3 Mini. A little bit pricier, I think, than some of the others, or they should check the Vellum leaderboard. And you may want to just go with a cheap one, like using GPT-4o Mini. I'm going to go with O3 Mini because we're going to try and have something that really pays attention to this. Now, I realize the first competitor in the list is GPT-4o Mini, and so it's a bit incestuous that some of the same OpenAI models are judging themselves. And it'll be interesting to see whether it thinks that the model from its own family is the winner. And we're not telling it the model names, we're only giving it a rank number, so it's not going to know. So we'll see how number 1 fares. Actually, the number 1's answer did look really good, so it might do very well. We will see, but we're letting O3 Mini make the call. Let's see how it does. Off it goes. It's thinking about it. It's taking its time. It's doing some reasoning, and here's the answer. So it doesn't put GPT-4o mini at the top. It puts model number 3, and you probably remember model number 2 was Anthropic. Model number 3, I forget, was it DeepSeek? We'll soon find out. So we are now going to load this, which has come back in perfect JSON, just as we wanted. We're going to load it into a dictionary. We're going to pluck out results. So now we're going to have this. We're going to iterate through it using, again, this enumerate approach. For each one, we're going to look at this string and subtract 1 and look it up in the competitors list and print the results. So if you're following me, this is just going to print out from best to worst the names of the models in our results. Drum roll, please. Here we go. So it was Gemini 2.0 Flash that is our winner, and GPT-4o Mini came second. Llama 3.3 came third, and then DeepSeek, and then Claude 3.7. But bottom of the list was the flailing Llama 3.2 that kind of gave up halfway. So there are the unscientific results of our judgment. Of course, it would be great fun for you to try this in a more scientific way. For example, you could have each of the different competitors come up with the rankings and then use that to take averages. That kind of thing would be a rather more interesting way of assessing it than just simply going with whatever O3 Mini tells us. So anyway, this was really interesting experiment designed to show you how you can collaborate between LLMs. So hopefully you were paying attention during this and the last lecture, and you've been able to identify which agentic workflow patterns were used in this example. Pattern or patterns. There might be a couple. If you're not sure, then go back through it and have a think and look back at the diagrams. And it might be some sort of hybrid or mishmash between a couple of them. And the exercise for you, first of all, do that. And then secondly, please pick one of the patterns that interests you and add that to this mix. The goal of this lab was twofold. First of all, to experiment with different APIs and see for yourself how the OpenAI API is used so frequently across many models, except Anthropic. And also to experiment with the sort of the basic API structure and the prompts. And the second goal was to experiment with this orchestration between models, asking a question, having multiple models answer, getting another model to assess the output. All this stuff is about interactions between models, dividing up a bigger problem into smaller problems, and a little bit of autonomy in terms of coming up with whatever question the first model wished to. So add another agentic design pattern. I'd love to see it. And then once you've done that, consider doing a PR and putting it in community contributions. There'll be instructions and the resources on how to do that. It's a good tip is to know to delete outputs of your notebook before you do it, so there's not lots of junk in there. And be sure that you're only pushing things in that community contributions folder. There'll be instructions. It'll be fabulous to see what you're doing and see some interesting agentic design patterns added in to this kind of exercise. And then final thought for this lab is about commercial implications. I do want to always bring it back to how you can think about this in a commercial setting. And to be honest, it's hard to be specific here because this is so universally applicable. Really, any time that you have something that you want to generate, something you want an LLM to take care of, these kinds of patterns, being able to send the same request to multiple LLMs, being able to then evaluate responses and either select the best or perhaps select a couple of best ones or use that to give feedback. All these kinds of patterns are used to increase the robustness and the accuracy of models and to be able to solve harder and harder problems. So really, this is, as I say, universally applicable. So you should be able to pick whatever commercial problem you can think of that you're applying Gen AI to, whether it's a summarization kind of problem or a generative problem, writing an email, building a document, writing a business requirements document, and you can think of how you could apply these kinds of techniques, sending the request to multiple models, voting on the best outcome. This is something that you should be able to apply to your projects right away. Well, we're tearing through this. It seems like just the other day that we were getting started. Well, it was just the other day. But here we are. We've now done the first 3 days filled in. You've learned about agentic workflows, agents and agentic patterns, and orchestrating between LLMs. And Next time, the next day, we are going to really get deeply into tools and tool use, which is such a fundamental part of agentic patterns and how everything else in this course is going to fit together. And so I'm really excited to talk to you about tools. I'll see you tomorrow.